A navigator on a ship sights a lighthouse at a bearing of north 36 degrees east. After traveling 8 miles at a heading of 332 degrees, the ship sights the lighthouse at a bearing of south 82 degrees east. How far is the ship from the lighthouse at the second sighting? I don't know, and I don't think I could figure this out without doing what? Yeah, I pretty much have to draw a picture here. So I'm going to draw the best picture I can. And I'll put in my coordinate axes, but instead of labeling x and y, I'm going to label the compass directions. So let's go north, south, east, and west. Okay, so let's start. Let's say you're in the ship. Pretend like you're in the ship. And so you're always at the origin if you're in the ship. Okay, you're always at 0, 0. But the ship is moving, so I'll show you how to take that into account as we go. So this is the ship at the first sighting. So let's call this point S1 here, just to give it a name. Actually, we could call it just A if you like, kind of to be consistent with what we did before. And then the lighthouse. So the ship sights a lighthouse at a bearing of north 36 degrees east. So think from the origin. This is a bearing now. So from the origin, go north and then east 36 degrees. So it's actually a heading of 36 degrees also, but we're expressing it in terms of a bearing. So north 36 degrees east. So what would that angle look like? Well, something like that. So that this angle here is 36 degrees. Now, where's the lighthouse at? It doesn't really matter where you put it. Let's suppose that this is, I'm not going to call this C or B right now. I'm going to call it LH so we know what's what. Let's suppose that's the lighthouse. And we don't know how far that lighthouse is, do we? Okay, after traveling 8 miles at a heading of 332 degrees, the ship sights the lighthouse again at a bearing of south 82 degrees east. Okay, so a heading of 32 degrees. So this is the ship. A is the ship. A is really the position of the ship. At the first sighting of the lighthouse. You don't have to write that down, but just so the notes are clear. So if the ship goes at a heading of 332 degrees, okay, you measure that from the north. So measure from the north and go 332 degrees. So not quite all the way around. So we're headed this direction. Everybody see that? This direction. So just draw a line. Draw a line of sight that looks like it's at a heading of 332 degrees. I don't know how far to draw it yet. So just draw it kind of like a line of sight. Right there. I know that it's 8 miles, but I want to make it look fairly realistic as far as the new bearing goes, south 82 degrees east. So somewhere on this line goes my ship at the second sighting. Okay, well, south 82 degrees east is almost all the way east, right? 90 degrees east from south is east, right? So I'm thinking as long as I put my ship at the second sighting, okay, if it were right here, then the lighthouse would be directly east of it. So I got to go a little bit north of that. So I'm going to make B the position of the ship at the second sighting of the lighthouse. And then I'm going to draw in a third side of this triangle I'm trying to create between B and the lighthouse. So not surprisingly, I set up a triangle. Now, I've left some stuff out, so I got to go back and fill it in. But you guys see how I got a triangle out of that? So the idea is we're going to use law of sines to find how far the ship is from the lighthouse at the second sighting. Okay? First, I got to fill in what I left out. So I know from A to B, how far is that? That's 8 miles. 8 miles. I won't put in the miles yet. I'll put that in at the end. I also know that the big angle here is 332, right? But I don't think I want that one. I think I want the little one because it's inside the triangle, isn't it? So what would be the leftover amount? It would be 28 degrees left over because a full rotation from the north would be 360 degrees, right? So would you agree that this little angle in here would be 28? So let's see, that's kind of hard to see. So let me zoom in. Okay, so this would be 28 degrees right there. Everybody see that? So I've already, if I just add 28 plus 36, I've already got angle A, don't I? I'm good to go there. Now, the problem is I'm wanting this distance, the distance to the lighthouse and the second sighting. What kind of name do I give that? Length A, right? Problem is I've got one angle in my, when I add these together, I've got one angle in my triangle. And I don't directly have the length of side A or any other angle. So I don't directly have enough information to apply the law of sines yet. But I can use what I'm given to figure out more angles. You just have to take your time and be careful here. Now, again, I haven't quite, I don't think, used everything I have here. I didn't say anything about this angle up here, and I do know something about it. Let's create another coordinate system. Remember, the ship that you're on is always at 0, 0 according to its coordinate system. So here's north, and here's your new coordinate system. Okay, so what bit of information have I not really used yet? The south 82 degrees east, right? So what angle would be south 82 degrees east? At the second sighting, the lighthouse is south 82 degrees east from the ship. So here's the ship right here, right? So this angle right here, this is the south right here. So south 82 degrees east would be that full angle right there, wouldn't it? Which is not the same as the angle inside the triangle, is it? It's not. But if you know a little bit about geometry, you can get it. Okay, so let me show you how. The picture becomes a mess after a while, as you can see. So I'm going to draw just a couple of, I'm going to pull out a couple of items from the picture so that I can make sense of this. I'm going to pull out this north-south line. Okay? And I'm going to pull out this the original north-south line. And I want you to notice something about this side of length 8 right here. This side of length 8 is a transversal. If I extend it, so I'm trying to draw this so that it looks parallel with that side of length 8. What do I mean by it? So from here to here, that's the side of length 8. And so this point right here, that's B, and this point right here is A. So does everybody see what I'm pulling out? Okay. Now, the only thing you have to remember from your geometry in this is that if you have two parallel lines cut by another line, that other line is called a transversal. All you have to remember is the angles that look equal are equal. The angles that look congruent are congruent. We don't have to prove that in here. It's just something we're going to use from geometry. So what? Well, what do I know this angle to be right here from the original picture? Isn't that the 28? Yeah. That's going to be the key, guys, to figuring out the missing bits of information from the picture. So this angle is 28. Does everybody, so take a look at both pictures. Does everybody see that? Any arguments there? Okay, so what other angle is 28? I mean, we want to know something about angle B, right? And we know the angle from this north-south line to this side A is 82 degrees, right? So we know that this full amount, this full blue angle in blue here is 82 degrees. But that's bigger than the angle we want. That's bigger than angle B, right? So can we use this 28 to say it's congruent to something else, another angle over here? Isn't it this smaller angle in here? So this would be 28 as well. I guess you'd call that alternate interior angles, right, if you remember your geometry. But in here, it's just angles that look equal are equal. So that means this angle, this shorter angle in here is 28, and that's the ball game. So this angle right here then, that angle right there is 28 degrees. Which makes, well, let's do it in black, I guess. Which makes this angle what? 82 minus 28. So angle B is 82 minus 28. What's that? 54. So the hardest part about this problem isn't the law of sines. It's coming up with the darn triangle. But now we've got enough information. So now we can finish up this example without further ado. So let's draw the triangle, because it does get to look like a mess after a while. So here's A once more, here's B, and here's the lighthouse, or C if you like. We know that this is length 8. We know that what's 28 plus 36? 64 maybe? So that's angle A, right? This angle plus this angle. And then we know that this guy is 54 degrees. We're looking for side A. Do we have enough information as drawn to get it yet? What other thing do we need? Don't we need the angle at the lighthouse? Yeah. If you want to, you could call that side C. So that angle C would equal what? I meant to say angle C. So that angle C would equal 180 minus the 54 minus the 64, which does turn out to be 62 degrees. Woo, that was a lot of work. But now the law of sines is, it's peanuts compared to what we just did. Who would have thought the geometry would be harder than the trigonometry? So set it up. What does the law of sines say about this side A? A in ratio to what? Sine 64 degrees should equal, what's the known ratio? 8 in ratio to sine 62. We really did need that, didn't we? And then is this easy enough to solve? You guys are all stunned. So shake it off. That one's relatively easy to solve, isn't it? Yeah, the picture was rough, but this isn't bad. What do I do to both sides? Multiply by sine 64. And we have it, basically. So we have A is equal to 8 sine 64 divided by sine 62. Let's get the answer accurate to 1 decimal place. And again, in the homework, you're just going to follow the directions. Round to 2 decimal places, then round it to 2. So what was that? Anybody run it through their calculator yet? So about 8.1. If we round off, 8.1 what? miles. That's it.